Let's give this problem here a try, number 9. What we want to do is solve this equation that involves this radical expression. Now we've got this radical on the left side isolated, right? It's just on the left side by itself, the one's on the right side. So let's start by squaring both sides. Now I'm going to indicate this. I'm going to write my parentheses here, getting the quantity square root 4x minus 5 squared equals 1 squared, indicating what I'm going to do. And now, on the left side, when you square a square root, we know the radical comes off. We'll get 4x minus 5 equals 1 squared, which is 1. Let's add this 5 to both sides, so we'll get 4x equals 6. Divide by 4, we'll get 6/4. We can reduce that to 3/2. And this is a potential solution. We need to check this. So let's write our check here. And we'll do that by saying if x equals 3/2, then, okay, let's put this 3/2 back into the original equation. Not anywhere here, but the 3/2 back into the original. It could be that we made an error down here, so we want to put the 3/2, our potential solution, right back here. So that'll give us the square root of 4 times 3/2 minus 5 equals 1. And now here, this 2 will divide into the 4 twice. So we'll now get the square root of, 2 times 3 is 6, minus 5 equals 1. This is the square root of 1 equals 1. 1 equals 1. It checks. So now we will claim that our solution set here is 3/2. Before we do any kind of computation in this problem, let's look at something here. Right here, we have a square root, and we know because of this sign that this is a positive number, right? This represents some positive quantity. So this we know is positive, and then we're adding a 7, and a 7 is positive. Now look, how can we add a positive number and a positive number together and get 0? This cannot happen. So what I'm thinking here is, I know that a positive number cannot be 0, so I'm thinking this equation is gonna have no solution. Now if I can see that right up front, I don't need to go through any computation. I know because I know something about numbers. But let's see what happens if we did not see that. So if we didn't see this, and we just start going, let's subtract the 7 so we can isolate the radical. So we're going to write this now as square root of x plus 9 equals -7. And now actually, before we go any further, what about this? Here's a positive number equaling a negative number. Okay, that can't happen, so that might tell you that there's no solution to this problem. But let's suppose that you didn't see that, so we'll start here with x plus 9 equals -7. And what we're going to do is, we've isolated the radical, let's square both sides. So what we're going to write now is this. We're going to write quantity square root of x plus 9 squared equals quantity -7 squared. On the left side, we're squaring the square root, so we know the radical comes off. So we get x plus 9 equals, now, -7 squared is 49. Let's subtract 9, so we'll get x equals 40. And that is, we think, a potential solution. But we need to check this. Now, from this work up here, I think there's no solution. And even down here, I think there's no solution. But when we went through this process, we got 40. That seems to be a solution, but let's check it. We should suspect that something's going to go wrong here. Let's do this up at the top here. So let's check as we usually do. We will write check, and let's say this. If x equals 40, then we're going to put this 40 back into the very original equation and see what happens. So we are going to get square root of 40 plus 9 plus 7 equals 0. This right here gives us the square root of 49 plus 7 equals 0. Square root of 49, 7, plus 7 equals 0. That gives us 14 equals 0, which is false, right? This is surely false. I mean, we can see here that 14 is not equal 0. We get a false statement if we run through this. So 14 doesn't work. We have nothing else left. So now we can claim that this equation has no solution.